Hey guys, welcome back to a new video and to the last part of our Ktor Android chat app course, in which we will actually take what we've built in the previous two videos and we're now going to deploy that. So you're actually going to be able to use the chat that we built together with your friends so they can sit at the other end of the world and chat with you. So that's what we're going to do in this video. For that, we're going to use Hostinger, which is actually the sponsor of this video. So thanks, Hostinger. I will show you how we will do this step by step. So we're going to use a VPS server here. That stands for Virtual Private Server. So in the end, that's just a virtual machine, a remote virtual machine, a Linux server. And we're going to set that up here. And also, why do I actually recommend using Hostinger here for your VPS server and not a different provider? Well, the biggest advantage I see actually is in the very, very simple dashboard. So in your H panel, configuring your server is super easy here. It's super intuitive, even if you're a beginner. I really like that. And also what I really like is they actually have, if you scroll down here, 24/7 support. Like, if anything is wrong with your server, they will help you out. So that's something that's really important with servers. I had that in the past, that I had issues with the server, and then like the support was only like available 8 hours a day, and this stuff usually happens when they are not active. So I can only recommend using Hostinger here for your server. And some of you might now ask themselves, why do we actually choose a VPS server here and not something like Heroku, for example, which is actually usually easier to deploy something to. However, with VPS servers, we just have a lot more control. So we, in the end, get a Linux machine with root access, and we can install anything we like. So nobody kind of limits us in that. If we use Heroku, in my experience, on the one hand, the costs rise very quickly. And if you want to install something like MongoDB, that's just not possible. So you actually have to take some kind of package from Heroku, and that then costs quite some money for, depending on how many users you have. Here on Linux, we can just install the free version of MongoDB. We have that on our local machine running. It's the quickest way we can actually access our database. So that's pretty cool. And does using a VPS server actually come with a disadvantage? Yes, it does, as pretty much everything in life. The disadvantage here is that it requires some technical knowledge, actually, because we actually just get a very empty Linux machine, an Ubuntu server, and we need to set that up on our own. So we have to know how to do that. However, if you're watching this video, then you will get a very simple step-by-step solution, and as long as you follow that, you won't have any problems deploying your server. So the first thing you actually need if you want to follow through this video and deploy your server is a VPS server, as I said. And yeah, then it's pretty cool that right now Hostinger actually has that Black Friday offer, which is still a limited offer, but it will be active when you're watching this video, when this comes out. So in the end, you can get up to 91% off of these VPS hosting plans, and also on shared hosting, stuff like that. We're going to use VPS hosting here, so that will be interesting for this video. You can simply go to hostinger.com and actually just click the link down below, then you will get to this. I will link everything here. Then you go to hosting, VPS hosting. And here you will see different plans. So now it of course depends what you want. You can see this goes up to VPS 8, which is way too overkill for what we are going to do here. If you're just planning to play around with that, to, just if you have the first time like an VPS server here, then the first plan here is totally enough if you're just using that with a few friends maybe. But of course, as your user base grows and if you're really serious with your project, then this won't be enough anymore because you only have like 1 terabyte of bandwidth. Then it totally depends how many users you have. I personally have this VPS 2 plan here for this video, but yeah, there are also enough scenarios in which it totally makes sense to pick one of these plans. But if you pick one of these, then you're probably already a little bit more experienced. So for the sake of this video, one of these 2 plans is totally enough. So once you're then decided for a plan, let's say, this one, then click select. You can choose your preferred billing period, 1 month, 12 months, 24 months, and 48 months. And you can pick your payment method. And you want to really click on have a coupon code, because you do have a coupon code, which is Philipp 7. And then you will get some more discount on even, on these 80% on their homepage. So that's pretty cool. If you have done that, it will look somehow like this for you. So this is basically an empty account in which I purchased this VPS server plan 2 here. I also have premium shared hosting, which we're not going to use, but this is important here for us. And yeah, I'm logged in here. So make sure to also be logged in. And we are now going to click on setup. So we can set up our own VPS server. Then the next window will look somehow like this. First of all, we need to choose a server name. This really is not so important what you choose here. I'll just leave what they recommend or what they suggest here. You can see the host name is the name of your virtual server, blah, blah, blah. You can use any domain as host name. It can be changed later. That's important. So pick anything you like. I'll just leave it as it is. And if you like, then you can simply change this later. Then you need to pick a location where your server actually is. United States is pre-selected here. So you should actually pick something here that is the closest to your main user base. So if most of your users are in India, then probably Singapore is the best because that's the closest to India, I guess. If your main user base is in the United States, then you pick United States, of course. I'm from Germany, so I'll pick Netherlands, which is pretty close. There we go. Now we actually also need to pick an operating system. So we have the option to pick any of these Linux versions or distributions actually. We are going to pick Ubuntu 20.04. And then we actually only need to choose a root password. So that will be the password we will use to log into our server using SSH. So in case you don't know SSH, that's just a protocol we use to kind of log into this remote machine here with our terminal, with our command line, and simply send commands to that server. So that's what we are going to do to control our server, to install new packages and stuff like that. So let's simply pick a password here, repeat that. We can also optionally pass an SSH key. We will need this in this video, but we're not going to do that here. I'll show you that later and what that is and all about that. Don't worry about that now. We can simply now click setup and hope we have everything we need. And it says your VPS has been created successfully. That looks pretty good. It can take from 5 to 60 minutes to fully build VPS. So I guess they sent you an email. Once that's actually finished, we can click on continue to control panel. And there we go. So this is now the dashboard for our VPS server. This is where you can manage the server. This is where you can reinstall Ubuntu if you really need that. So if you messed something up and you really want to reset everything, this is the place where you can do that. You get all the information, like for example, the IP address here, which is pretty important. You can see we get the current server status, which is currently executing. We can reboot our server. We can change the root password and stuff like that. You can see backups. So this is pretty much, the main control hub here. And I really like how simple it is to use that here. Okay, there we go back. Looks pretty good. Our server is running and I hope the same is happening for you. The next step is actually that we want to go to this website, if you're using Windows at least. This is the so-called git bash. So we're now going to spend the rest of the video in our terminal or in our command line. And in Windows, we do have the normal Windows command line. However, there is one command we actually need, which is to generate the SSH key and copy to our server. I will explain what all that means in a moment when we do that. However, to execute that command on Windows, we need this git bash, which is very, very similar to the Linux terminal. So yeah, you can just simply download that. You don't need to consider much for the installation, just clicking next all the time. And then we're actually ready to go. And if you're using Mac or Linux here, then you don't need to do this. Then you can simply use your normal terminal. However, on Windows, we do need that. The next step is that we actually generate this SSH key pair. So let me explain. SSH, as I already said, is the protocol we will use to actually connect to our server. So if we now take a look here in our Hostinger dashboard, we have the server IP address and we have our server username. These two in combination are used to actually connect to the server using our command line. And then via the command line, we can simply install packages like MongoDB, like Java, everything that's used to and needed to run a Ktor server. And normally, to connect to a server via SSH, you just enter your username, so root, followed by an @ and then the IP address. And then you're prompted to enter your password that you actually chose when you created the server, and you're good to go. However, later this video, we will actually set up something that we can very easily automatically deploy our Ktor server to our hosting or VPS server. So we will just be able to execute a single Gradle task in IntelliJ. And by doing that, it will automatically deploy the Ktor. So it will build that, generate a jar file, upload the jar file, run it on our server, everything automatic. We're going to do that. And for that, our Gradle actually needs access to the SSH server. So we could provide our password in our source code, in our Gradle file, but that is not what we want. So instead, we will use a different way of authenticating ourselves, and that is via SSH keys. So when we generate these SSH keys, we on the one hand have a public key. That's public, that's not a secret. That will be on our server. So we will push this key to our server, and then we will have a private key, which is kind of compatible with that public key. And the private key will only be on our machine here. And then as soon as we connect that, using our private key, we don't need to enter a password. So let's actually do that. And to do that, you need to go to your user folder. So in Windows, that's just, you have a users folder and then your Windows account. For Linux and macOS, you also have a user folder. And in there, you will have a .ssh folder. This is the interesting folder we want to open here, because that contains all of our keys, our SSH keys that we have on our machine. If you never dealt with stuff like that, this will look pretty empty for you. However, we want to now generate a new one. So we can right click here if you're on Windows, and we can say git bash here. So that will open the git bash in this specific directory. If you are on Linux or Mac, then you just open your terminal here. So git bash here. There we go. And now the rest of the video will be a lot of copy and pasting. That's just how it is if you're dealing with terminal. I will explain every step we do. And you can also find a very detailed gist in this video's description. So I will give you just a step-by-step tutorial and solution here, how you can deploy everything. So you don't need to type this off. You can simply go to this gist and copy these commands and paste them here. So the first thing we want to do here is we want to paste this command. This will now generate this SSH key pair that I talked about, so a public and a private key. And it just specifies some options like the algorithm here, the key type, like how long it is. We're just going to press enter here. And now we need to enter a file in which we want to save that key. We want to call that something like something that's related to our server, like chat, for example, or Ktor chat, I don't know. Just like this, we press enter. We need to enter a passphrase. No, we actually don't need to do that. You could also add an additional passphrase for that key, but we don't want to do that because we just want to be able to provide that key and give our Gradle task access. So we're just going to skip this by pressing enter, enter again, and there we go. This is now how it will look like if the key was generated. If we take a look in our .ssh folder, here you can see on the one hand we have Ktor chat and Ktor chat.pub. So that pub file is the public key, which is public, and that is not a secret. This is the secret file, which you really should keep on your own. So you shouldn't share this with anybody. And that will be used to now authenticate to our server. Before that will actually work, we need to actually take this public key and push it to our server. And we can do this with a so-called SSH copy ID command. And this is exactly the command that we need git bash for. So that is not contained in the normal Windows command line. So yeah, this will be the latest point where you will realize that you really need git bash. So that will be followed up with an I for the identification file, I think. And now we are going to specify the name we chose, so Ktor chat. And now we need to specify the server and the username we want to push this to. So that will be root, because we are root users on our VPS servers. And now we need to follow that up with an @ and our IP address of the server. That will now be individual for you. So you will find that here in your hosting your dashboard, right here. You copy this, go back to your terminal, paste this, or not. Let me copy again. Can't I please paste this? This is a little bit weird. Not sure why I can't paste this. Copy. Paste. Okay, now it works. I don't know why I didn't before, but yeah. If this is how it looks like for you, and you actually entered your IP, then you're good to go. So now feel free to press enter. And yes, you just want to type yes here if you get the same message. And you need to enter your password for that server once now to copy over that key. That will be the password you chose here on your hosting your dashboard. So I will now enter mine. And you can see if everything was successful. You see number of keys added 1, so that was your key. And now if you want to log into your server, you can simply use that key file. So you can say SSH, that is what we use to connect to the server. We're going to use -I to use our SSH key, which will be Ktor chat, root, and we follow this up with our IP address again. So I think this should be enough. Yeah, and you can see now I am actually connected to this Ubuntu server. And now everything we type here won't be actually executed on our Windows machine or on our local machine. Instead, it will be executed here on our VPS server. So we're now currently on that remote machine. Now, the first thing we should do here is actually to update the dependencies. So in Ubuntu, we can simply install tons of packages, and to just update the dependencies that it knows where to get these packages, we can say apt update. So often you see sudo apt update. Sudo is just a command to execute this as a root user, but since we're already logged in as a root user here, we don't need that. So you can simply, I don't know why it switches up always. We can simply say apt update, and you can see it will do a bunch of stuff here. When that's done, you will see this command line again. And now the first step we need to do is to actually install Java. So of course, in the end, our Ktor server runs on the JVM, the Java virtual machine. We will also generate a jar file, so an executable file of our server, upload that to our server and execute it here. That's pretty much what we're going to do. And to be able to execute it, we just need Java. We can install this Java package by saying apt-get install default-jdk, pressing enter, and that will probably take a while. You can see we want to continue here, yes, so we type a Y, press enter, and now it's basically downloading Java here on the server. It will do a lot of stuff, and when that is done, I'll see you back. Okay, Java is actually installed. The next step is we need to change something in our SSH config. So what we can say is nano, that is the command to open an editor here in our terminal window, nano/etc/ssh/sshd_config. So that's just a config file in which we want to add something here. You can see this is how it looks like for me, and it should also look like that for you. So in here, I'm actually now going to paste a string that you will find in my gist file, as I said. It's a very long string. You don't want to type this off. Now it works. Okay, it's that string. And why do we need to do this? So it's basically this with this kex algorithms. So we will later use a tool in Gradle that will connect to the server. And that just uses some kind of key exchange algorithm. Won't go into the details here. That is not configured by default, you can say. And with including this line, we just make sure that we won't face any issues with that later. If you've pasted this here in this file, you can press Ctrl S to save this, and then Ctrl X to actually get out of this nano window again. Now, since we changed this config file, we want to restart this SSHD service to just apply the changes. We can do that by using systemctl. Is it restart or is it, yeah, systemctl restart SSHD. So that should actually restart the service, which already happened here. Okay, So the next thing we need to take care of is actually creating a Linux service, a so-called systemd service. What is that and why do we need that? Well, in the end, you need to think of it that way. We will have our jar file here on our server, which is the executable server, and that will run here. But we actually also need to take care that this is actually always running, because a server should always be running. So if this crashes, we would like to restart it. If our server is actually restarted, we want to automatically also launch our Ktor backend with that. All that is stuff we need to configure. And for that, we can use so-called systemd services on Ubuntu. And to create that, we again want to open a nano window in /etc/systemd/system. And now we can pick a name for the service. You can choose anything here. I will pick chat.service. So it's important that this ends with .service, but what comes before is up to you. Pressing enter, and this will now create an empty file. And then please now take a look in the gist in this description and simply paste this stuff here. We can actually remove all these new lines. I don't know why it pasted these. So this is now just the configuration for our chat service. I won't go into the details here, but all we really do is we give it a description. We say, okay, this should actually be launched after the server is connected to the internet. Some configuration here. We have a simple service type. We always want to restart it if something fails. We want to execute it as the root user. And this is the important line here. This is actually what the service will do when we execute it. So later on, we will have this chat server jar, which we're going to push from our IntelliJ directly to our server. And this contains everything from our server. So all the source code, everything. It's just like an exe file in Windows, executable file. And with this command, we're just going to execute that. So every time our Linux machine will also reboot, then it will relaunch this server jar here on reboot. If you've done that, you can press Ctrl S again to save this and Ctrl X to get out of this. Now, since we defined that service now, we can, for example, start it and just try this out. We can again use systemctl, start this time, and we want to say chat because that is how we named our service. So pressing enter here, everything went well. So the service is now started. Then we want to say systemctl enable chat. That will create a so-called symlink. So this command will now make sure that this chat service is automatically launched when our server here is launched. Then the next step is actually to make sure that the port our server is running on is actually open. So that means that our Linux machine here is actually accepting traffic at that port, so incoming requests, because that's of course needed to be able to talk to our Ktor server. For that, we want to paste something I can't paste again, so I will copy this again. One moment, here, copy, paste, this one, IP tables, blah, blah, blah. So what we're now going to do is, this is not opening the port yet, this is rather redirecting the traffic. So with IP tables, we can define these network rules. And what we're going to say here is the port 80, which is the default HTTP port, we want to redirect the traffic. So everything that comes into port 80 will be redirected to the 8080 port, which is the port our server will run on. So that way, we don't always need to enter like our IP address here, followed by 8080 in the URL bar. Instead, we can simply do this, which will just lead the traffic to the default HTTP port, which is 80, and that will then redirect this to 8080, which our server is running on. So simply hit enter here. Then the next command will be this, also IP tables. This is now used to open these ports. So now to make sure that the port 80 is open, that HTTP is accepting traffic, which should always be the case. Let's just do this, and we can click the up arrow to have the same command again, and just do the same for 80. Oops, 80. Come on, 8. Like this. Now I have it, and pressing enter again. Now, The thing about these IP tables rules is rather that they are not persistent. So as soon as we relaunch our Linux server, these rules will be gone. To fix that, we can install a package called iptables persistent. We can do that using apt-get install iptables-persistent. We want to press Y here for yes to accept that. And then this window will open up. We simply want to click yes, so enter again. And that now successfully saved our iptables rules. Okay, is there actually something missing here server side for the configuration? Yes, there is something missing. We need to actually install MongoDB because our server, of course, needs access to that. So when our jar file here runs, it tries to actually access the local MongoDB instance. And if there is no instance, then nothing will work in the end. For that, we first of all need to paste this, which you will also find in the gist down below. This gist will be your best friend. This is just used to, that it in the end finds that Mongo package. So we just press enter here, and we want to do the same for another command, which you'll also find there, which is this one. So this one will add the repo to MongoDB, clicking enter, and now we're actually ready to install that. Before that, we actually want to say apt-get update. So it actually takes these changes or these keys and repos we added here and just make sure that we have these. You can see here it actually includes that now. And then we can say apt-get install mongodb-org. So that will now install MongoDB. We press Y again to accept that, which is also a little bit bigger package. And I'll see you back when that is installed. Okay, there we go. It is installed. MongoDB will also be such a systemctl service. So we first want to say unmask MongoD. It's called MongoD. This is a little bit confusing that the service is not called MongoDB. So make sure to not include the B here at the end. Pressing enter. And then we also want to say systemctl enable MongoD to just make sure that it is also automatically launched when we boot up. So pressing enter, the symlink was created. So far, so good. And then as a last thing here, we just want to restart that service. So systemctl restart MongoD. Of course, you could do a lot more configuration here for MongoDB. Like if you want to remotely connect to this MongoDB instance here, like from your Mongo Compass or so, then you need to set that up like that. Then you need to add authentication to MongoDB. Then you need to choose a password. You need to open that. So you need to allow that also other IPs can access that. Right now, the only IP that's allowed is the local host basically here. So only the server itself, which is pretty secure, but it is definitely understandable if you want to access that from your Windows machine as well. So then you need to set up some security rules, which I won't go into here. Okay, so now that our actual VPS server is properly configured, we now need to configure the rest in our IntelliJ IDE, in our Gradle file mostly, to basically just set up that automatic deployment. So in the end, we can just have a single terminal command here using our Gradle wrapper to deploy our server. So as soon as we made any changes here in our source code, that will then run some tasks, like it will generate a jar file. It will then take the jar file and push it to our server. It will then send commands to the server to basically restart the chat server and then make sure that everything is live. Of course, in a production environment, there is a little bit more that belongs to this process. So if you really want to set up some kind of continuous deployment pipelines, then you also usually have some continuous integration pipelines to make sure that all your tests run successfully before actually deploying that. So it shouldn't be too easy to deploy changes because that can also quickly break something. But I think for the sake of this video, it's pretty cool to show you how this works. And it always makes sense to adjust this to your personal needs. So the first thing we want to make sure is in our application config file that the port is actually 8080 because that's what we chose in our VPS server setup. So in case you did not change this, then everything is good. If you change it, then please now change it back to 8080. On my machine, that does not work locally because another program is running on that port. But for deployment, that's now fine to temporarily change that. The next steps are all in build.gradle. So let's open that. And I actually don't see really a reason to show you how I copy paste everything here. So I will now do this, and that's a lot of stuff that has difficult syntax and you quickly make mistakes. So I just advise you to copy and paste everything as well. I will go through everything line by line, explain what happens here, why everything happens. But yeah, I will now modify this a little bit and then get back to you. Okay, welcome back. I actually changed up my Gradle file here. You can find the same file I'm using here down in this video's description in my GitHub repository of this chat app server. Let's now actually go through this and I'll show you the changes I actually made. First of all, I included a new Gradle plugin, which is this so-called shadow plugin. The shadow plugin is used to actually generate the jar file out of our source code. So the jar file, as I already said, basically just contains all your source code. It contains your resources that you potentially use, all that stuff. And yeah, that's of course what we need to do to be able to execute that in the end on our VPS server. Then I added this line here, that we set this property main class name. This is just needed by the shadow plugin, so it actually knows where the main class is. It just needs that property, and we can get this with this command here, main class.get, which comes from Gradle. I added this Gradle plugin portal to actually find this shadow plugin. It's just the repository of that. And now when we scroll down, it actually gets more interesting here, because I added this so-called SSH and task. So that's first of all just a configuration, and we use that here to actually include this dependency. So the SSH and task will be used to actually get access to SSH and SCP in Gradle. So on the one hand, SSH is something you've already seen in this video, so that we can send commands, like shell commands, to our remote server. That is of course needed when we want to automatically deploy that here. So we later want to say systemctl restart and then our chat service. Then I also mentioned the SCP protocol. SCP is used to copy files in the end. So as soon as we generated our jar file here, we of course want to push that to our server. And that does not work with SSH. Instead, we use SCP for that. So we simply get the jar file from our local machine to our server. So then you are going to see, yeah, this is just the shadow jar task. So we can now generate a jar file by executing a Gradle task in our terminal. We can actually try this. Then you'll see how this works. So here in your terminal, make sure you're actually in this root folder. We can say Gradle W for Gradle wrapper, and then say shadow jar. And then that will execute the shadow jar plugin. It will build your project and it will then generate the jar file. When that is done, I will get back to you, which it is already. You can see build successful. That looks good. And if we now take a look in our build folder under libs, then this is actually the name of our jar file. And this is our jar file. This is not only the name of that. So that is just that was just generated by this plugin, by this shadow plugin, and this contains everything. So if we run this, then we run our server. So that was just for demonstration. Later on, we will have another task that will also call this shadow jar task for us, so we don't need to do that manually. Just that you know how we can actually generate this jar file. Then this is now what I meant with this difficult syntax, because this and plugin can only be really used with the Groovy version of Gradle, so not the Kotlin DSL one. However, there is this with Groovy builder function, which kind of is the migration tool for that. So we can still use Groovy Gradle things in Kotlin DSL, but then it gets this difficult syntax here with all these quotation marks and stuff like that. Just paste this, it will work. Yeah, so we just configure that here. We define these two tasks, on the one hand SCP and SSH, so we can actually use these in our own task here, which I call deploy. So this is the task that we will then execute to deploy everything, to build the jar file, to push it to the server, to restart the server, stuff like that. So if we now take a look in this task, let's try to understand what this does. We first of all say it depends on clean and shadow jar. So using depends on, we can just use that to make sure that these two tasks actually run before this one. So when we run deploy, it will also run clean and shadow jar. So it will clean our project and then build the jar file. And then we again use this Groovy builder. We say do last. And yeah, here just for as kind of utility tool, we generate a temporary noun host file, which just contains the host names we already know on this local machine. And we're then going to delete this afterwards here in the finally block. Not really too important, to be honest. What's more important is this stuff. So on the one hand, we need to define a root, a user where we want to connect to, which is root here for us, because we're going to, that's basically just the user that our VPS server gave us. Then we need to define a host name, which is your IP address. And I actually also need to update that. Do I have that here? No. Let's actually go back to my server dashboard, copy this IP address, and go back here and actually paste this. So make sure to, of course, replace this with your IP address. The PK is the private key. So that's not the key file that we need to actually connect to our server via SSH or SCP. That's what we did at the very beginning of this video. So if we now actually take a look in our folder here, our .ssh folder, this is the private key. And Gradle, of course, now needs access to that to use it to authenticate itself, to not need a password. So I will now take this key file, copy it, and go to my root package here, chat app server, create a new directory, or actually before that, I want to add that to gitignore because the private key should definitely not be in GitHub. So we want to say /keys. So we just exclude the keys folder here. Then we go to our root package, new directory, call this keys. And now we're simply going to paste our private key, just like that. So when you pasted that, you can simply close this file, which again, you shouldn't show anyone. Back in your build.gradle file, you want to make sure that you change the name of that to Ktor chat or whatever you called your primary key. And then we have a jar file name. So that's the name of the jar file that was generated. You can see it's basically this name on the left side here, com.pl coding Ktor-chat, then the version-all. Since I copied that from my preparation project, that's still contained in the name, let's remove that. So that's how my jar file is called. It will automatically include the version here. So we make that a placeholder and then we're good to go. And now with all this information, we can start to push our stuff to the server. So in this task, we now say, okay, we want to use the scp command to copy a file to the server. The file will just be in our build folder libs jar file name. So just our jar file. We want to copy it to our corresponding server. So we say user at our IP address. Then we need this colon here to refer to the file system. And this will be the path at which I will personally do this. We specify a key file. We trust this host, specify the known hosts file. And we're now going to do that for pretty much the rest here as well. So for this SSH task, we're just going to specify a command instead. So here we're not going to copy a file. Instead, we're going to send a command. This is the move command, which is used to rename a file. So we just go to our server and we rename the jar file name, which has this very long, ugly name, this one here. And that can differ. We don't always want to change our service on Linux to match this jar file. So that's why we simply rename this. So we rename the jar file to simply chat server jar. Then after that, we send the command systemctl stop chat and systemctl start chat, which is our service on Linux. So that makes sure that our Ktor server actually reboots. And that's pretty much it for this task. So it's pretty cool. And we can then simply go to the terminal and say Gradle W deploy. And that will now do everything for us to push that to our server. However, we're not fully done yet. This is most of it, not everything. A very minor thing we need to do on our server is we need to make sure that we actually have this folder. So this root chat folder, otherwise it won't work. So back in my terminal here, let's make sure we're actually in the correct folder. You can check that with pwd. I am in root, so we can say make dir to make a directory. And how did I call this? Chat. So we just want to make sure we have a chat directory in here. And in that directory, we will then push our server jar. And I think this should be everything to be able to run this. Let's actually try this out by going to terminal and say Gradle W deploy and pressing enter. Now, pretty much anything could happen. Would be pretty cool if it works right away. If not, then we will figure it out and see what's actually the issue. Now it will just run all of this, like first clean, shadow jar, and then this stuff to actually deploy our server. And it says build successful. That actually looks pretty cool. Let's take a look in our server. So right now we're in our root package. Let's cd, so we change the directory to chat. And if we now type ls to list all files, then we can see there's our server jar. So that was just successfully pushed from IntelliJ to our server using our Gradle task. That is pretty cool. And the last little bit of configuration we need to do is in our Android app. So I've opened that. This is really not a lot here. We only really need to change the IP address in our message service. So here, make sure that you actually use this. So the IP address of your VPS server, which you again get from a dashboard. We don't need the port here because we forward everything from the default HTTP port to the 28080. So this would be fine. And we want to make sure to paste the same thing here for WebSockets. Simply put that in here. And I would say we just try this out. So I'm running this on 2 devices here on my emulators. And I'm actually excited if this works. This would be pretty cool if it works right away, because this deployment stuff can always be a little bit tricky. But that would only really say that the step-by-step solution here, like the gist, is really solid and it works. So 1, 2, here we go. Let's try to join. Choosing Philipp here. Okay, we at least didn't get an error. Join as well. And when we now send hi, oh, there it is, it works. Perfect. We could of course clear the text here, but this is now effectively running through our own server. So you can sit anywhere in the world and this will now work. So we can reply to that. Hello there. Send this. Yeah, we should really actually clear the text afterwards. But yeah, you should know how this works. Just setting the state to an empty text again. The important thing is that this actually works. Let's also check that MongoDB works. If we leave this, so we basically go back, then we actually, oh, we see the message twice. That's interesting. I will need to look into that. I don't know why that happens here. But let's relaunch this and try it again. Okay, that's really interesting. So saying Peter. Yeah, so we do see the messages twice. I don't know why, and I will get back to you once I found that out. Okay, I'm pretty sure I have found the reason. I haven't tried it out yet, but if we take a look here in our Ktor server, in the room controller, in the send message function, we actually insert a message into our database for every single member. That's of course a stupid mistake. Sorry for that, but let's take this and actually put it outside of this for loop. So then we just insert the message once in the database and then send the message to all members. So that should still happen. Luckily, since we have our Gradle task, we can simply hit Gradle W deploy to apply the changes to our server. We'll wait until that is actually finished here. And we can also already actually relaunch our app here in Android Studio. Take a look here if everything is successful. It is, so it should be applied now. Of course, we will still see the current messages twice because they are saved in the database. So I will join as Philipp. There we go. Yeah, I added some test messages here. I'll just join with whatever here. And we can write hello YouTube, something like that. Send this. I'll leave the chat, join back. And yeah, now you can see it's just in here once. So that now seems to work fine. Pretty cool. So you now have a working chat that you can use with any of your friends, no matter where they are, which is super cool. In case you actually want to build apps with a really solid architecture and you want to see a course about that, you can simply click on the left side here to see a dictionary app that we built with clean architecture. Or you can also decide to make a Node app here on the right to learn how to do that with clean architecture.